Hi, good evening to all.
Yeah, good evening.
Let's wait for 2-3 minutes and then we will start.
Okay, okay, no problem.
Uh, Good evening again to all of you. So we have waited for around 10 minutes, joined from 7. So let's start now the session. Otherwise we'll be late. I hope that everyone can see my screen. Can anyone confirm?
Yes, we can see.
Yes,
Yeah, we can see.
Thank you. So today the discussion will be based on the drone hardware fundamentals part 4. So it would include the communication systems and the telemetry. Now, under the communication systems and telemetry, we will discuss of about 6 topics. First one would be for the radio frequency communication fundamentals. Second is the control link systems. Third is the telemetry and the data transmission. Fourth is the video and the imaging systems. Fifth, network integration and connectivity. Sixth is the security and the anti-jamming technologies. Okay. So communication systems from the critical link between the drone platforms and the ground-based operators, enabling real-time control, data transmission, and mission coordination. Modern drone communication architecture encompass multiple radio frequency bands, protocols, and data types to support diverse operational requirements ranging from basic manual control to complex autonomous missions with high bandwidth sensor data streaming. So, why this communication system and telemetry is important in the integration of drone, or when we talk about an UAV as a whole, we talk basically about two systems. One is the communication module and the other is the communication box. So communication module and the communication box, they will be communicating with each other through a secured data channel or through a secured link. That secure data channel or the secured communication link is basically based on the RF wave propagation. So the radio frequency wave propagation, I don't know whether all of you are aware about this or not. So this is basically based on the aspect that when a data or a signal is transmitted through a communication channel, whether the communication channel is wired or wireless, how the behavior of that data or signal will be when it is received at the farthest end. So that behavior or the response of the data or the signal, that will be depending on the radio frequency based transmission or the wave propagation. So there are multiple types of modulation at the transmission side, demodulation at the receiver side, proper encryption at the transmission side, proper decryption at the receiving side, all are being followed. And this aspect of radio frequency based communication system is based on certain spot frequency and an appreciable bandwidth. Say if we talk about the ISM band, where we take 2.4 gigahertz as the secured frequency for communicating between the communication module and the communication box. So 2.4 gigahertz will be based on certain bandwidth. Generally, in the narrow channel-based communication system, we take 10 megahertz, 20 megahertz, 40 megahertz as the channel bandwidth. So these channel bandwidth are being governed by different kind of SAW filters or surface acoustic wave filters, which are placed at the reception side. So these SAW filters are responsible to tune the different channel bandwidths, like for 5 megahertz, 10 megahertz, 20 megahertz, or 40 megahertz. So the center frequency of transmission will be 2.4 gigahertz, but the F1 and the F2 frequency points, or basically the lower frequency and the upper frequency point, will be based on this bandwidth. So if I take, say, the channel bandwidth as 40 megahertz and my center frequency is 2.4 gigahertz, then 2.4 gigahertz minus 20 megahertz will be the frequency for F1, and 2.4 gigahertz plus 20 megahertz will be the frequency for the upper frequency band or F2, so that my channel bandwidth can be 40 megahertz. Now, this secured communication link between the UAV and the ground control station or the ground-based operator, why does it important? Because it enable the real-time control, the data transmission, and the mission coordination. Because I think I have told you in the earlier classes that when we receive the data at the ground control station through certain UI or the interfaces, there usually we check two kind of feeds. One is the control command feed and the other is the telemetry data feed, which is basically the numeric data that is visible in the UI screen, apart from the surveillance video that is captured on real-time basis. So including the latency, what we discussed yesterday, that it should not be more than 10 millisecond, we capture the data or get the data at the ground control station, and reflection of the data at the UI interface is through the certain parameters. Say we check the CC data, we check the telemetry data, we check the lat long data, we check the video feed for the different channel. As I told you yesterday, that generally for a quadcopter or this kind of drone architecture, we usually follow two channel, one channel 0, one channel 1. So if this channel 0 or channel 1 is connected to the UAV, and at the ground control station, we check the video feed or the telemetry data feed. We usually check what kind of data is received from them. So those kind of data we generally get in the Excel format, and from there we usually plot the graphical representation to check that for the transmission, what is the overall signal strength, what is the overall telemetry data feed, what is the overall video data feed that we got from the drone. So these plottings are necessary to compare the data with the historic data. So in real time, we get some data from the telemetry, from the video, from the channel command, and we compare that with the prehistoric flight to check whether there is any kind of abnormality in the behavior or any kind of deviation from the mean data value. So suppose my signal strength that is estimated for a 10-kilometer range flight is around 70 dBc per hertz. So if we get some deviation from 70 dBc per hertz, say the data from the real-time plot, it comes around 75 dBc per hertz, then that abnormality should need to be captured, and that need to be fed to the design team. That data basically fed by the drone pilot or the field testing team. They will feed that data to the design team to check that why that abnormality came. Then further tuning in the software code or further tuning in the hardware module or in the RF communication or in the antenna, all these things need to be taken care. Okay. So this is basically 2.4 gigahertz 6-channel transmitter plus FSIA 6B receiver. This is basically for your uh, knowledge that how the transmitter or the receiver looks like. So generally this is for the amateur drone kit. Usually for sophisticated drone, like for defense applications, the system integration part or the overall console looks different. So there the ground control station or the com box is something which is opaque in nature. So there is no display directly attached to the communication box. So from the communication box through the LAN cable or the RJ45 connectivity, the communication is being fed to certain other UI console. Like I have used some platform from GETAC. So from the GETAC, we have the we have a separate kind of display console where we have certain kind of software inbuilt into it, and through which we can check the different plots that came as a real-time feed. So we can check the telemetry feed, we can check the video feed from there. Okay. Okay. Radio frequency communication fundamentals. So frequency bands and allocations. 2.4 gigahertz ISM band. ISM means industrial, scientific, and medical band. The 2.4 gigahertz industrial, scientific, and medical band represents the most widely used frequency range for drone communication due to its global availability and license-free operation. This band spans 2.4 to 2.485 gigahertz and supports various communication protocols, including Wi-Fi, Bluetooth, and proprietary radio control systems. So 2.4 gigahertz is basically a free band in the ISM communication band, which is being used by most of the drone manufacturer. Now, this frequency band spans from a range of 2.4 gigahertz to 2.485 gigahertz. So anyone, any frequency band in between these can be the center frequency. So if any kind of transmitter or any kind of receiver is not available, particularly for 2.4 gigahertz, suppose it is available for 2.42 gigahertz, that is also we can use in the design, or maximum till 2.485 gigahertz, that also we can use in the design, but not more than that or not below this value. Okay. And this supports the various communication protocol, including Wi-Fi, Bluetooth, and proprietary radio control systems. Generally, the Wi-Fi that is being used here, it is basically the Wi-Fi 4. So whatever modules are being designed for this 2.4 to 2.485 gigahertz, this is basically for Wi-Fi 4. For Wi-Fi 6 also, or Wi-Fi 7 also, we can use the 2.4 to 2.485 gigahertz frequency band, but those modules are a bit costlier compared to the Wi-Fi 4 communication modules. And there, the communication data rate is a bit faster compared to the Wi-Fi 4. In the traditional or the legacy designs, generally the Wi-Fi 4 modules are used. Nowadays, these Wi-Fi 4 modules are being replaced by the Wi-Fi 6 or the Wi-Fi 7. Similarly, for the Bluetooth, in the earlier legacy designs, the Bluetooth, conventional Bluetooth is used, but nowadays the Bluetooth low energy is used. Okay. So the proprietary radio control systems, including the Wi-Fi, Bluetooth, are all based on this 2.4 gigahertz ISM band. The 2.4 GHz band offers excellent propagation characteristics with moderate range capability, typically achieving 1 to 5 kilometer line of sight communication depending on transmitter power and antenna design. So this is very, very important. So we have taken 2.4 GHz frequency band. Now I want to hover the flight to a range of say 20 kilometer, say 50 kilometer, say 100 kilometer. My frequency band is not doubled. My frequency band is still kept at 2.4 gigahertz, and I want to increase the range of the flight and thereby the endurance of the flight. So for that, if I take the normal 2.4 gigahertz frequency band and it is connected or communicated through a wireless NAL module where the transmitter power or the transmitted power is say 30 dBm. 30 dBm corresponds to 1 watt. Now, if I want to increase the range of my drone, you are understanding, say initially I have taken the communication frequency band as 2.4 gigahertz and the wireless NAN module is communicating at 2.4 gigahertz. But the problem is at 2.4 gigahertz, I am transmitting an RF power of 30 dBm. So 30 dBm corresponds to 1 watt. Now with respect to this 1 watt, my overall range for the drone is coming around 5 kilometer. Now I want to increase my range and thereby increase the endurance of my flight. So for that, I need to increase the RF transmitted power. Now, every wireless LAN module, whether you take it from any manufacturer, it will have an integrated RF transmitter. So it will have an integrated power amplifier. That RF power amplifier will be able to transmit the power up till a certain uh, wattage value. Up till a certain wattage value. Say if I take 30 dBm or 1 watt, so till 1 watt, that wireless LAN module will be compatible to transmit the RF power, thereby putting my range till 5 kilometer with an endurance say around 30 minutes or 45 minutes, say for example. Now I want to increase my range till 10 times. So I want to increase my range from 5 kilometer to 50 kilometer and my endurance from 45 minutes, say 2-3 hours. How to do that? So in the RF transmitter chain, when we will design the RF transmitter circuitry, so there in the path of the wireless LAN module, after the wireless LAN module, we have to connect an RF power amplifier. That RF power amplifier will be able to transmit or amplify the power level. How? Say we are transmitting from the wireless LAN module a power level of 30 dBm, right? So 30 dBm will be corresponding to 1 watt. So for 1 watt, we are getting a range of 5 kilometer. Now I want to increase the range to 50 kilometer. So I have to increase the range till 10 times. So in my RF transmitter chain, the RF power also we need to increase to 10 times. It is not logically correct, but you can say approximately 10 times because these are a logarithmic increment. It is not an arithmetical linear increment. So if I increase the RF power by 10 times, automatically my range will be increased by 10 times from 5 kilometer to 50 kilometer. That is not true. But for the sake of telling the example, I am citing this. So if my range is 30 dBm or 1 watt, I need to increase my range. I need to add up RF power amplifier after the wireless LAN module to increase my RF power capability. So how to do that? So for that, we need to do a cascading of several power amplifier. We need to use a pre-amplifier. We need to use a final amplifier. So like that, we need to cascade the power amplifier module because every RF power amplifier will be having different gain blocks. So we need to add the different gain blocks. We need to add up the gain. We need to check the linear region of the power amplifier. We need to check the 1 dB compression point of the power amplifier. Accordingly, there is an RF power calculation on an logic level, how we can add the different power components with respect to dB and dBm. And finally, we can get the watt or the RF power output corresponding to a range of 50 kilometer. So in that way, we need to tune the RF power amplifier circuitry, because the wireless NAND module that is being purchased from certain manufacturer or supplier that is capable of transmitting the RF power till certain limit. It cannot go beyond that. So in order to extend the RF power capability, we need to add the additional RF power amplifier blocks. Okay. However, this band suffers from significant interference due to widespread use by consumer electronics, Wi-Fi networks, and other radio control devices. So now you are increasing the RF power, your range got increased, you are taking the flight. So from 5 kilometer, you went to 50 kilometer. At the same point of time, you need to understand that there are adjacent cellular towers or cellular network which is hovering in the vicinity or which is there in the vicinity of your flight, of your drone, which will also interfere with your 2.4 gigahertz secured communication frequency band, because you are putting your communication linking from the communication module to the communication box through a secured path. In spite of that also, as the frequency is centered at 2.4 gigahertz, additional frequency bands in the vicinity, which is also running at 2.4 gigahertz, will interfere with your secured communication band of 2.4 gigahertz, thereby introducing perturbations or interference in the signal path. In order to avoid that, we need to optimize the signals. So that is why the adjacent channel optimized receiver topology or technology is being used in the UAV architecture. So what is the significance of this adjacent channel optimized receiver? This adjacent channel optimized receiver will be responsible to mitigate the co-channel interference, because when you are transmitting a signal at 2.4 gigahertz from the communication module to the communication box or the ground control station, co-channel interference will come into picture. In order to nullify this co-channel interference, we need to use the adjacent channel optimized receiver. Okay, so that will nullify the impact of the adjacent 2.4 gigahertz frequency band and thereby providing a secured path between your communication module and the communication box. 5.8 gigahertz band. The 5.8 gigahertz band provides higher bandwidth capability and reduced interference compared to 2.4 gigahertz, making it particularly suitable for high definition video transmission and high speed data links. This band support wider channel bandwidth, enabling higher data rates essential for real-time video streaming and telemetry application. So we talked about 2.4 gigahertz. So apart from the 2.4 gigahertz, the sub-6 gigahertz band comprises of the 5.8 gigahertz frequency band. So when we talk about the Wi-Fi 6 communication protocol or the Wi-Fi 6 modules, so for the Wi-Fi 4 module, we can put for 2.4 gigahertz. We can proceed with 2.4 gigahertz. But for the Wi-Fi 6 module, for the Wi-Fi 7 propagation, we cannot rely on the 2.4 gigahertz band. So at that point of time, your frequency band will increase. So the frequency band that is being used for the Wi-Fi 6 communication or the Wi-Fi 6 module selection, it will be 5.8 gigahertz band. Now 5.8 gigahertz band, the significance is it will provide higher bandwidth capability, have the higher bandwidth capability, and it will have the impact of the reduced interference compared to 2.4 gigahertz, because 2.4 gigahertz is very much prevalent. So there you can have all the adjacent channels running at 2.4 gigahertz, which will have the impact of the co-channel interference much more. But for 5.8 gigahertz, this co-channel interference is optimized right from the beginning. So this 5.8 gigahertz band is particularly suitable for high definition video transmission and high speed data links. So the reliability is much more. The security aspect is much more. So if we talk about the fail-safe mechanism where flawlessly data transmission would happen, so that is basically true for 5.8 gigahertz band. This band supports wider channel bandwidth, enabling higher data rates essential for real-time video streaming and telemetry application. Propagation characteristics at 5.8 GHz exhibit reduced range compared to lower frequencies but offer improved immunity to multipath interference. The higher frequency enables smaller antenna designs while maintaining directional gain beneficial for compact drone platforms with space constraint. Now, if we talk about how the signal will propagate, because on one side we have the transmitter and the other side we have the receiver. So for transmitter, we need to connect with the transmitting antenna. For the receiver, we need to connect with the receiving antenna. Now, when we are communicating the signal or transmitting the signal or having the linking at 2.4 gigahertz frequency band, so the antenna accordingly need to be selected based on the 2.4 gigahertz frequency band. Now, when we are selecting the frequency at 5.8 gigahertz, the antenna need to be selected for 5.8 gigahertz. 2.04 gigahertz frequency band antenna will not support for 5.8 gigahertz unless and until it is dual band. In modern days, we get antennas which support the dual frequency band or the tri frequency band. So in that case, if we take an antenna, say there is a uh, manufacturer for antenna, most of the companies use that is called tau glass. So if you use some antennas from tau glass, which are omnidirectional antenna supporting 2.4 gigahertz and 5.8 gigahertz, they will be the dual band antenna. So for this dual band antenna, if we connect the modules at 2.4 gigahertz or 5.8 gigahertz, at both the frequencies it will work. But if it is a single band antenna at 2.4 gigahertz, that single band antenna cannot work for 5.8 gigahertz. So two separate antennas for single band, one at 2.4 and other at 5.8 need to be used. So when the frequency is increased, it is a thumb rule. Basically, when the frequency is increased, the wavelength basically reduced because velocity is equal to frequency into wavelength. So if my frequency is increased, my wavelength will be reduced. If my wavelength is reduced, then the length or the overall length, effective length of the antenna will also reduce. So for 5.8 gigahertz frequency band, whatever antenna length we will be having, that will not be the same for 2.4 gigahertz frequency band. Okay. The higher frequency enables smaller antenna designs. That is why the effective length of the antenna is smaller at higher frequency, while maintaining directional gain beneficial for compact drone applications with space constraints. So two types of antennas can be used in generally for the drone application. One is the omnidirectional antenna and the other is the directional antenna. What is the difference between omnidirectional antenna and directional antenna? Can anyone tell me?
Omni is what is radiates in all direction with 360-degree.
Correct.
Directional will have particular direction.
Correct. So
Ah.
omnidirectional antenna is basically isotropic. Why isotropic? Because it will have the radiation pattern or the radiation intensity in all the directions same. But for directional antenna, it is not the same. Directional antenna will be having the radiation pattern particularly in one direction. So if we take an azimuthal plot, because for an antenna, if you go a deeper dive into the technical aspect of antenna, so there are a lot many parameters based on which antenna, either directional antenna or a omnidirectional antenna or a helical antenna or a phased array antenna or a grid antenna, whatever types of antenna you use. So there are a lot many parameters based on which an antenna is used. Out of that, 3-4 parameters are very, very important. One is the gain of the antenna. Second is the impedance of the antenna. Third is the VSWR of the antenna. And fourth is the radiation pattern of the antenna. Now, radiation of the pattern of the antenna that comes in the two plane. One is called the E plane and the other is called the H plane. H plane is basically the horizontal plane and E plane is basically the elevation plane or the azimuthal plane. So in the E plane or the H plane for the directional antenna, whatever lobes or the patterns you will get, that will not be the same for the omnidirectional antenna. For omnidirectional antenna, across 360-degree, the isotropic or the intensity or the radiation pattern will be the same. But for directional antenna, it will be directed only in one particular direction. So if we use directional antenna in our drone design, then the communication box also need to be tuned in the direction of the directional antenna. Otherwise, what will happen? We will not get the in real time the true data. We will get a lot of garbage data because your receiving station is at the ground control station, the communication box. that will be communicating in the communication module or the UAV. In the UAV, you are connecting directional antenna. So where the pattern of the directional antenna is, in which inclination or which angle it is transmitting the data, that is very, very important. So from the data sheet, you need to figure out that parameter or that value, and accordingly, you need to move your communication module, communication box accordingly. That is why communication box are connected with a motor. Whenever directional antenna is used or in any kind of flight motion, initially from the pre-start, from the initial start, your communication box is connected with a motor, and automatically it will adjust or calibrate with the orientation of the UAV. And after that calibration is done, it is automatically get fixed to a particular direction. After that, you cannot touch the communication box. If you touch the communication box after the calibration is done with the motor, then the data will all get lost, or you will get garbage data in the reception side. Okay.
Does it mean that higher frequency, smaller antenna should have the omnidirectional?
No, it does not mean always the same. You can use omnidirectional antenna, but for higher bandwidth or for precise data streaming, you need to use the directional antenna. In directional antenna, you can get more gain. In omnidirectional antenna, always you cannot get more gain for an antenna. But with directional antenna, you can get more gain. The disadvantage is that in directional antenna, the radiation pattern is restricted to one particular direction, which is not the same for omnidirectional antenna. It is depending on your application. You need to choose the particular antenna.
Thank you.
Propagation characteristics at 5.8 GHz exhibit reduced range compared to lower frequencies, but offer improved immunity to multipath interference. The higher frequency enables smaller antenna designs while maintaining directional gain, beneficial for compact drone platforms with space constraints. Now, sub 1 GHz band, long range communication application utilize sub 1 GHz frequency band, including 433 MHz, 868 MHz, and 915 MHz, depending on regional regulations. Yesterday, we talked about the GPS, where I talked about the tri-band GPS antennas and all these stuffs. So there, these band frequencies are utilized: 433 megahertz, 868 megahertz, 915 megahertz. So these are basically the sub 1 gigahertz band. Why? Because you see this frequency band in the megahertz that is below 1000 megahertz or 1 gigahertz. Okay, so depending on the regional regulations, so if you use the dual band GPS receiver, or if you use the dual band modules, so there the frequency will be restricted to 2 frequency band. If we use the tri-band module, so there the frequency will be restricted to 3 frequency bands. So for safer side, we can take the tri-band modules, so we don't need to change the design. If the for the tri-band modules, the antenna supporting will be tri-band. So with the tri-band antenna, if we go for the dual band, automatically it will support the dual band. Maximum it can support 3 band. So if we go for the, you took tri-band antenna, but we go for the dual band receiver, automatically the antenna will support the 2 frequency bands. So based on the regional regulations, this frequency band, either dual band or tri-band, that need to be selected. So accordingly, the module will get changed. These frequencies provide superior propagation characteristics with significantly extended range capability, often achieving 10 to 50 kilometers communication distance in optimal conditions. Lower frequency bands exhibit enhanced diffraction properties, enabling communication through obstacles and terrain features that would block higher frequency signals. However, these bands typically support lower data rates and may require larger antenna structures. So if we go for the lower frequency bands, we are not talking about the gigahertz frequency bands now. We are going in the UHF band where the frequency is in megahertz. So if we go for the UHF band, so that exhibit what? That exhibit the enhanced diffraction properties. So in diffraction, we basically have two types of diffraction. One is the Fresnel diffraction and that is the Fraunhofer diffraction. Generally with drone, I have seen it goes with the Fresnel diffraction, enabling communication through obstacles and terrain features that would block higher frequency signals. However, these bands typically support lower data rates and may require larger antenna structure. So for the UHF frequency band, you will not be able to go with the directional or the omnidirectional antenna. There you need to have more bigger antenna structure like the grid array antenna or the phased array antenna or the larger patch antenna. So all these types of antenna with bigger aperture need to be used for this kind of frequency bands. Okay. So any question so far?
I have a question about it's a general question.
Uh-huh.
Normally, this general radio,
Uh-huh.
uh, each utilizes 2.4 gigahertz channel, 2.4 gigahertz ISM band for
Uh-huh.
radio and the FM channels. I'm talking
Uh-huh.
about
Uh-huh.
frequencies. They utilize this 2.4 gigahertz ISM band.
Are you asking me they are using 2.4 or not?
No, no, I'm just asking this band spans between 2.4 and 2.48 gigahertz to
Uh-huh.
2.485 gigahertz because it
Uh-huh.
supports various communication protocols, including radio control also.
Hmm.
So that general radio might be utilizing this band frequency 2.400 between 2.40 and 2.485 gigahertz. Is it correct? Hello, 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 hello.
Sorry, I was speaking on mute. The
Okay,
mute button got pressed. Anyway,
okay.
no.
No, no. My
Hmm.
question was normal radio FM channels.
Uh-huh.
They utilize this band, which spans between 2.4000 to 2.485 gigahertz, and which supports the radio control system also. So, is it
Correct.
correct? So, these normal radio stations and the FM channels also will be in between these bands. Is it correct?
Definitely. So if we want to use this ISM band and
Uh,
utilize 2.4 gigahertz, so we
uh,
need to utilize the center frequency as 2.4 and
mm,
share the bandwidth. So if you
okay.
talk about the FM channels, you will see
Mm,
the bandwidth is not the same. If we
okay.
tune the channels at the same bandwidth, then
Uh,
two FM channels will interfere with each other and you will
okay.
not be able to hear any one of them.
Okay.
That
Got
basically is called the uh, system of cacophony. In cacophony, what happens? In
mm,
cacophony, two, three channels, they interfere among each other, both having the same frequency, same bandwidth, and ultimately the modulation get a very complex kind of modulation, and an audience or in audio effect, you will not be able to hear anything. If you see the beat pattern for a cacophony signal, it will be a jumble of signal containing all the frequency band, having the same bandwidth. That's why in the FM channel, you will see they will be utilizing one central frequency band, but they will be dividing the bandwidth. Bandwidth will not be the same. Say one channel bandwidth is 20 megahertz, the other bandwidth channel is 40 megahertz, the other is 10 megahertz, something like that. They will shift or tune the bandwidth amongst them.
okay. With the higher bandwidth will capability must it is must between
No,
5.8 gigahertz band.
no, 5.8 gigahertz is a separate frequency band.
Okay.
2.4 have nothing to do with 5.8.
Okay.
5.8 spectrum is separate, 2.4 gigahertz is separate. 2.4 basically comes under L band. So under the L band, what frequency you are using, that you cannot compare with the sub 6 gigahertz band
Okay.
because the modulation format, the data transmission capability, the bandwidth significance, the circuitry, the different kind of filtering mechanisms, that will automatically change compared to that of the 5.8.
Okay. Thank you.
So on drones, we will always use isotropic antennas, right? Na? And
No,
on
no,
JCS
no, no,
side,
no, no,
no.
no, no, no. In drone
Mhm.
side also, you can use directional antenna. It is not always true that you need to use the omnidirectional or the isotropic antenna. You can use the directional antenna. And in the GCS side, basically in the communication box side, there are two types of entities. One is
Mhm.
the HHRBT and the other is called the communication box. The HHRBT are connected with different kind of radiating antennas. Either it is omnidirectional or directional. And the communication box, which is bigger in size, that usually encompass a patch antenna or a grid antenna or a phased array antenna. So the radiation pattern, the characteristics of those antennas are totally different compared to that of the directional or the omnidirectional antenna. Because in the communication box, as that is a reception medium, receiving medium, and that can be connected with multiple drones at the same time. So the aperture area of the antenna should be bigger. You cannot compare that with the UAV.
Okay, okay, thank you.
Okay, any other questions on RF?
So for a video transmission, then we have to use 5.8, or on 2.4 also it will go
For
good.
2.4,
Means
for 2.4, you can see some kind of hopping in the video. The streaming should not be that much okay. Because why I told you na, for 2.4 gigahertz, lot many cellular interference will come into picture, which is not the same for 5.8 gigahertz. So for 5.8 gigahertz, when you are streaming the video in real time, you will see the flawless video. The bandwidth requirement or the data rate requirement will be much more for the 5.8 compared to that of 2.4, but the quality of the video feed will increase with 5.8.
okay, okay, thank you. Bandwidth anyway it will increase na for 5.8.
Correct. Bandwidth increase होगा
Hmm.
ही होगा.
Hmm.
Bandwidth will be increased, the data rate capability, the computing power will be increased, lot many processing power will get enhanced, your RF power requirement will get enhanced. RF power requirement जो आपका 24 2.4 गीगाहर्ट्ज में था, वो 5.8 के लिए सेम नहीं रहेगा ना, और भी ज्यादा बूस्टिंग
Hmm.
पावर लगेगा उसको.
Right. Yes. Okay. Thank you. Then why we don't use 5.8, or we can use any it
We
is
can use na. I have
any.
used 5.8 gigahertz. Now in the drones, the defense are asking for, they are asking for 5.8 gigahertz. They are not asking for 2.4 gigahertz. 2.4 gigahertz तो आपको रहेगा ही. 2.4
Hmm.
gigahertz तो फंडामेंटल. 5.8 भी आपको देना पड़ेगा.
Okay. So for defense also we are using same frequency band. So it won't affect कि जो भी enemy countries है, they will use the same frequency for jamming and all.
That is why in the spoofing of the signal, the jamming of the signals, lot many new technologies are coming na. You cannot
Hmm.
encrypt the data. The method of encryption, the method of decryption, that is also getting changed. The modulation techniques are getting changed. So whatever modulation we are using in the earlier days for this 2.4 gigahertz frequency band, you cannot use the same for 5.8 gigahertz frequency band. Because आप जब when you will encompass your 5.8 gigahertz module, 2.4 gigahertz module in the UAV side, and that will fly in the border area. Suppose that side is China and this side is India, you are flying the drone. So China will always try to put the anti-jamming devices and nullify the drone effect. But sometimes it does not get impacted, na. Automatically the
Correct.
signals are transmitted. How it is getting transmitted? So the type of modulation, the type of encryption is totally different.
Okay. And the frequency will also suppose if I'm transmitting some frequency at of 5.8, and
हाँ.
I know this 5 point like you know that I'm transmitting on 5.8, you will put the jamming on 5.8 gigahertz, then my signal will get
ना
jammed na?
ना
No,
खाली
no.
5.8 से मतलब नहीं है. You need to know the
Oh,
bandwidth also. 5.8 is the
oh,
center
is it?
frequency. We see, I have told you in the beginning, there are two center frequency. If I denote it by FC, then
Hmm.
there are two other frequency points, which is called F1 and F2.
Right.
What is F1? If we have the bandwidth, then FC
Hmm.
minus bandwidth by 2 will be your F1. And FC plus bandwidth by 2 will be your F2. So you need to know the
Oh.
F1 and the F2. जो दुश्मन है
Hmm.
मैं on a मजाक में बोल रहा हूँ. So
हाँ.
they will not be knowing your bandwidth.
Okay. For jamming bandwidth also to be known, not just the
हाँ,
carrier frequency.
डेफिनेटली. खाली कैरियर फ्रीक्वेंसी से क्या होगा?
मुझे लगा
You
कि
also
कैरियर
know.
फ्रीक्वेंसी से
No,
ही
no, no.
जैमिंग कर देंगे एंड देन
नहीं नहीं, हाउ
वी
हाउ
कांट ट्रांसमिट.
तले तो कभी ट्रांसमिशन होगा ही नहीं.
ओके. लाइक सपोज आई एम इमिटिंग, आई एम रडार है और रडार में मैं 5.8 इमिट कर रहा हूँ, सामने वाला सेम फ्रीक्वेंसी 5.8 का इमिट करके आई थॉट कि इट विल ब्लॉक द
नो,
थिंग.
खाली 5.8 gigahertz is the 5.8 gigahertz is your center frequency, but there is
ओके.
some lower frequency band and the upper frequency band apart from your center frequency. उससे भी डेटा ट्रांसमिशन होता है.
ओके.
5.8 तो आपका सेंटर फ्रीक्वेंसी, स्पॉट फ्रीक्वेंसी है, वो तो आपको चाहिए ही.
हम्म.
अदरवाइज यू कैन नॉट डिफाइन द टोटल फ्रीक्वेंसी स्पैन. बट आपका टोटल फ्रीक्वेंसी स्पैन जो है, उसमें खाली 5.8 नहीं आएगा, आपका लोअर फ्रीक्वेंसी स्पैन, अपर फ्रीक्वेंसी स्पैन वो भी आएगा।
Okay. So matlab to jam, I should know all these three frequencies.
All these
Is
three
it?
frequencies.
Okay, okay, okay. ठीक
That
है.
is our,
Thank you.
that is the, what to say, that is the USP of your design, na. I told you what,
Mm-hmm.
that in the receiver side we can use the frequency, the SAW filter frequency of 5 megahertz, 10 megahertz, 20 megahertz, 40 megahertz. That is depending on me. I can use 50 megahertz also. अगर
Hmm.
चाइना को पता चल गया वो 40 मेगाहर्ट्ज का बैंडविड्थ यूज कर रहा है, तो मैं डिजाइन को चेंज करके 50 मेगाहर्ट्ज कर दूंगा।
Yes.
द सॉ फिल्टर अगर मेरा चेंज हो गया, so the reception frequency, the F1 and the F2 will also get changed.
Right, right. Yes.
See, whenever it is for the knowledge of everybody, whenever you are reading a data sheet for any kind of wireless LAN module transmitting a frequency of 2.4 gigahertz or 5.8 gigahertz, you will not see only one frequency band there. You will see multiple frequency band there, the different frequency band there. Why that is important? Because whenever the modulation will come, it will modulate the frequency, na? It will generate the harmonics.
Hmm.
If you see in the spectrum analyzer, your center frequency is 2.4, but you will get the additional spikes also there. Those additional spikes are nothing but the harmonics. You can get the first harmonic, you can get the second harmonic, you can get the third harmonic. If I am sure about my topology or technology, and I know that someone will be spoofing or jamming my signal, I will eventually do what? I will use my center frequency at 2.4 and I will send the data at the first harmonic. Who will know that I am sending that the first harmonic? I am the designer. I only know that I am sending the data at 2 point at the first harmony. The
Okay.
other party will not be knowing. They will be knowing that they are transmitting at 2.4, but that is not correct. I am transmitting the data at the first harmonic of 2.4. How will you know?
Hmm.
That is the
Okay.
USP for every designs. Otherwise the drone communication तो कभी establish होगा ही नहीं.
Hmm. Correct.
I
See,
think
Russia and Ukraine, they are using lot in the drones in the war.
Hmm.
अगर यूक्रेन को पता ही होगा कि कौन से फ्रीक्वेंसी में आके वो फेंकेगा, वो फ्रीक्वेंसी से वो जैमिंग नहीं कर देगा। चलो
Hmm.
रशिया कैसे आपका वर्क कर रहा है विद द ड्रोन?
Correct. Correct.
I think because of this interference or jamming from enemy, this quantum technology will be used for. It will make some barriers so that enemy will not be able to jam our frequencies.
See, there is pros and cons with every technology. Now you are telling with quantum technology, they will not be able to do any kind of penetration, but ultimately that day will become when the modules and everything, or the electronic component with respect to the quantum is available. So the
Mhm.
anti penetrating component with respect to the quantum is also available. Like initially when the drone was developed, at that time the jamming or when the GPS was developed, this kind of jamming mechanisms not came na, jamming mechanisms came later. तो टेक्नोलॉजी का इन्वेंशन और एक्सटेंशन वैसे ही होता है, जिसका पॉजिटिव कुछ है तो नेगेटिव तो ऑटोमेटिकली उसका आएगा।
Yeah, yeah,
जो
correct.
क्वांटम है वो निश टेक्नोलॉजी है, उसमें टनलिंग इफेक्ट के थ्रू यू कैन डू लॉट मेनी थिंग्स, बट उसको टनलिंग को कैसे अवॉइड किया जा सकता है सो दैट इंटरफेरेंस कैन कम इन एंड यू कैन नलिफाई द इफेक्ट, वो भी डेवलप हो जाएगा, आज नहीं तो कल तो हो ही जाएगा।
Correct, correct, absolutely. And the other side also, some technology will come to jam those
हाँ
interference.
हाँ, पहले क्या
Yeah,
होता
correct.
था, पहले क्या होता था मैं आपको बोलता हूँ। अराउंड 10-12 years बैक when the drone was developed और ड्रोन
Mm.
was flying, तो तब आपका ओपोनेंट, मैंने डिफेंस सेक्टर में ही बोल रहा हूँ, जब ड्रोन
Mm.
यूज करते थे, तब मान लो पाकिस्तान का टेरिटरी या चाइना का टेरिटरी, तब उन लोगों को उतना नहीं पता था कि एंटी जैमर से या जैमर से उसको मैं नीचे गिरा दूं या कुछ उसको स्पूफिंग कर दूं। इंडिया भी वैसे चाइना का नहीं करता था। जब से ये जैमिंग डिवाइस या स्पूफिंग डिवाइस आ गया है, ये ड्रोन में ही इसको फिट कर दे रहा है।
Okay. Yeah,
माने
suppose
नाउ
that,
आई एम वर्किंग ऑन सम स्पेसिफिकेशन, आई शुड नॉट डिस्क्लोज, एनीवे माने थोड़ा बहुत बोलता हूँ
uh,
कि इन द ड्रोन आर्किटेक्चर इटसेल्फ वी आर यूजिंग द जैमिंग कैपेबिलिटी। माने मुझे बाहर से कुछ अलग से यूज करने का जरूरत नहीं है, इट विल बी ऑल कॉन्सील्ड इनसाइड द ड्रोन बॉडी इटसेल्फ। माने मेरा जो ऑटो पायलट होगा, मैं जो कल
uh,
डिस्कस कर रहा था, वो ऑटो
uh,
पायलट के अंदर ही मैं एक सेपरेट मॉड्यूल रख दूंगा ऑन जैमिंग, आपको पता
okay,
ही नहीं चलेगा मैं जैमिंग यूज कर रहा हूँ।
correct. Anti-jamming set will be there on the
इनसाइड,
uh,
इनसाइड
inside
में ही
inside
रहेगा।
the
हाँ,
correct. Yeah,
मान लो
wonderful.
आप
That is
बॉर्डर लाइन में फ्लाई कर रहे हो, और उस तरफ से आपका चाइना का भी कुछ फ्लाई कर रहा है, तो चाइना का जो ड्रोन है और मेरे इंडिया का जो ड्रोन है, इंडिया के ड्रोन के अंदर में एंटी जमिंग लगा दिया तो ऑटोमेटिकली वो नालीफाई कर देगा चाइना के ड्रोन को। आपको अलग से कुछ जैमर यूज करने का जरूरत नहीं है।
Okay.
Sir, if you are using the swarm of drones, how
हाँ,
to avoid the cacophony, sir?
नो, कैकोफोनी इज नॉट रिलेटेड टू द ड्रोन swarm. Cacophony is related when you are using all the signals of the same frequency band. आपका फ्रीक्वेंसी बैंड भी सेम है, आपका बैंडविड्थ भी सेम है, और सेम स्पैन में आप उसको यूज कर रहे हो। ड्रोन स्वार्म में क्या होता है, यू आर यूजिंग से 20 ड्रोन्स इन द ड्रोन स्वार्म, एंड आउट ऑफ द 20 ड्रोन्स one particular drone will behave as the master and the 19 other drone will behave as the slave. तो जो मेरा मास्टर ड्रोन है, that will be communicating to the ground station with the communication box, and the 19 other drones will not be communicating with the communication box directly. They will be communicating on a one-to-one basis with the master drone, and the master drone will send the signal to the communication box. So there will be not be cacophony there. You are getting
So
my
it's
point?
a sort of IoT, sir.
Which one?
Sort of IoT technology is used in the for
No, no,
the
no, no,
swarm.
no, 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 no. This drone swarm is based on the secured RF communication only, but there the frequency span, the bandwidth are all in the distributed manner. So suppose my total bandwidth span is 50 megahertz. So that 50 megahertz bandwidth span is divided among the 20 drones which are being used in the drone swarm along with the master. So if in the drone swarm I am using 20 drones, so one particular drone will be characterized as my master, and the 19 other drones will be communicated as the characterized as the slave. So the 19 drone, each of the 19 drone will be communicating on a one-to-one basis with my master, and the master will be sending that one-to-one data to the ground control station
Thank
by
you, sir.
bandwidth sharing.
Yeah, I have another question because we are talking about the swarm drone.
Uh-huh.
There is IUAV network protocols. So, what is exactly use of that network topology?
Can you elaborate
I
one?
IUAV is also the network protocol which is
Hmm.
widely used in EAV designing. So, what is that?
IUAV I have not came across in the
Okay.
protocols that we have used in our company or the
Mhm.
organization for the drone development. So
Okay.
their IUAV so far I have not seen or used. I
Okay.
don't know that whether in the drone swarm that is used or not. But what I can tell you, what we have employed for the drone swarm is that we have not
Okay.
used the 5.8 gigahertz module. We have used 2.4 gigahertz module only. But for the
Okay.
2.4 gigahertz in our drone swarm for the defense, the requirement was we need to use the 10 drones. So 10 drone, the group of 10 drone will be performing the drone swarm activity because they want to do some kind of what to say, uh, some kind of weapon check, some kind of bombing check, all these things to this drone swarm activity. So that kind of activity need to be checked by considering 2.4 gigahertz and sharing the bandwidth. So
Okay.
for 10 drone, we are using some secured modulation techniques that is based on the frequency modulation scheme, the advanced frequency modulation scheme, and there we are dividing the bandwidth. So basically, you know the concept of spectrum spectrum.
No, no. Please explain to us so that we will come to know.
So frequency hopping space spectrum,
Hmm.
FHSS, you can Google it. So frequency hopping space spectrum is basically a technology in which the frequency is being modulated through different bandwidth schemes. That bandwidth scheme will be defined by the user. So now if we need to use a drone swarm of 10 drones, so there we have selected some certain frequency band, and that frequency band is modulated or divided as per our FHSS scheme on a frequency hopping space spectrum scheme. And based on that, the algorithm is being written so that one drone can communicate with that nine other drone. One drone will be treating as the master, and it can communicate with the nine other drone who will be treated as a slave.
Okay. Got it. Thank you.
Okay, and just one more. During the drone show, when we are using hundreds of drone at that time, so how the drone show has been carried out and how each drone knows its position every time.
No, these are basically pre-programmed type of drone activity. These are basically used for, say, the endurance of that flight is very, very limited. You will not see that kind of drone show is lasting for 2 hour, 3 hour. It will be restricted for few minutes, say 20 minutes, 15 minutes. The span is very less. The endurance is very less. So for less endurance activity, you can pre-program any kind of thing because it will not go beyond your line of sight.
Hmm.
The drone swarm can go beyond your line of sight, but the drone show that is happening in front of audiences, that cannot go beyond your line of sight. You cannot see. So it will be under your visual line of sight. So when the activity will be demonstrated under your visual line of sight, so the endurance, the RF communication, everything will be restricted to very much limited figure, not some kind of value which you need to tune, which need to program, manipulate. All these things will not be there. So suppose you want to do some kind of patriotic activity of India based on the drone. Say we are using 100 number of drones in that case, say an example.
Hmm.
And that
Hmm.
total activity will last for about 15 minutes. So for that 15 minutes, each of the 100 drone number from 1 to 100, all are programmed in a sequential manner. And during the flight time, that all flight will not take at the same instance. When the VTOL flight will take na for this drone activity, mane, to do this kind of visual demonstration and all these things, it will be
Hmm.
sequentially time bound. माने वन ड्रोन सपोज चला गया ऊपर, उसके बाद 10 सेकंड के बाद और एक ड्रोन गया, तो 10 सेकंड के बाद जब एक ड्रोन गया, तो पहले ड्रोन वो 10 सेकंड में तो और भी डिस्टेंस चला गया, तो अकॉर्डिंगली दे
Hmm.
विल मेंटेन द गैप एंड लाइकवाइज दे विल विजुअलाइज अ पोर्ट्रे, माने दे विल पोर्ट्रे द थिंग इन फ्रंट ऑफ यू. ये सब
Okay.
एक सॉफ्टवेयर के थ्रू पहले प्रोग्राम्ड होता है. वो विजुअली दिखा जाता है कि कैसे उसका लुक एंड फील आएगा. उसके लिए
Hmm.
कोरियोग्राफर रहता है. दे हैव द स्टूडियो टीम. दे विल डिफाइन ऑल दोस थिंग्स ऑन द ग्राउंड फ्लोर. माने उसका जो सॉफ्टवेयर रहता है, वो सॉफ्टवेयर के थ्रू उसको प्रोग्राम करके पहले दिखा जाता है वो कैसे दिखेगा. उसके बाद अल्टीमेटली वो फील्ड टेस्टिंग में जाता है. ये जो शो आप दिखते
Oh.
हो ट्वेंटी रिपब्लिक डे के टाइम में, या ये सब इवेंट में जब ड्रोन के यूज में बहुत कुछ चीजें दिखाए जाते हैं, दीज आर ऑल प्री प्रोग्राम्ड एक्टिविटी अराउंड 4-5 मंथ्स बैक. वो सब ट्रायल एंड एरर करते 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 एक स्ट्रीमलाइन मोशन में आता है. माने व्हेन यू विल गेट द विजुअल इफेक्ट, देन उसको पब्लिकली डेमोन्स्ट्रेट किया जाता है.
Okay. So, मतलब all drones are working in autonomous mode.
हाँ, इन टैंडेम टू ईच अदर. ऑटोनोमस मोड में
Tandem
तो
to each.
काम ऑटोनोमस मोड में तो
Hmm.
काम करना ही पड़ेगा, अदरवाइज तो उसका
Hmm.
कुछ वैल्यू नहीं है. बट ये सब प्री प्रोग्राम बेसिस में होता है. माने सपोज आपके पास 100 ड्रोन है, आप ABCDEF करके 100 ड्रोन का नेमिंग दे दिया, तो ए
Hmm.
ड्रोन का एक्टिविटी जो होगा वो बी ड्रोन के साथ सेम टू सेम नहीं होगा. ए
Right.
ड्रोन अगर ऑल्टीट्यूड H1 तक जाता है, तो बी ड्रोन ऑल्टीट्यूड H2 तक जाएगा. H1 और H2 के
Hmm.
बीच में गैप रहेगा, तो ही तो एक आपका पिक्टोरियल टाइप का फॉर्मेशन आएगा.
Yes.
एक के
Yes.
ऊपर एक
Correct.
नहीं आएगा. माने
Hmm.
H1 ऑल्टीट्यूड में ए ड्रोन का जो एक्टिविटी रहेगा, H1 ऑल्टीट्यूड में बी ड्रोन का सेम एक्टिविटी नहीं रहेगा, वो H1 में रहेगा ही नहीं.
Hmm.
अदरवाइज तो
Correct.
फाउल हो जाएगा ना, इट विल गेट डिस्ट्रैक्टेड.
Yes. Yes. They have to work in tandem basically.
हाँ.
Yes. Yes. ठीक है. Thank you. Yeah.
So is it a simulation that is used before?
Definitely. You need to simulate, you need to tune the entire program beforehand. Then only you can deploy that program in the drone architecture, in the drone firmware, in the drone logic, and then you can take off the show.
Acha, what are the names of these simulation softwares? Is there any software open source technology available?
No, 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 no.
So is it a proprietary one that every means for
These
defense
are
sector?
basically the licensed node block license or the perpetual
Okay,
license version. You need
okay,
to buy it from the distributor or the supplier, and you
okay,
can get it for a 1 year span. 1 year के बाद आपको renew करना पड़ेगा.
okay. But these are available in India or
Definitely, definitely. There
okay,
are distributors. I can give you some name also. There is some
Achha,
software from ANSYS. So
okay,
ANSYS का बहुत सारे डिजाइन सॉफ्टवेयर है, सिमुलेटिंग
okay,
सॉफ्टवेयर है, through which all these programs activity you can do. There is some सॉफ्टवेयर फ्रॉम डैनफोस। डैनफोस ही है। तो डैनफोस से कुछ सॉफ्टवेयर से यू कैन बाइट फ्रॉम देम। तो दीज आर बेसिकली जो हम लोग सिमुलेटिंग ड्रोन शो के लिए बोल रहा है। सो दीज आर बेसिकली द सॉफ्टवेयर यूज इन द कोरियोग्राफी पर्पस। तो इसके साथ एनसीस या डैनफोस का सॉफ्टवेयर का लेना देना नहीं है। दोज आर सेपरेट सॉफ्टवेयर। वन सॉफ्टवेयर आउट ऑफ दैट इज शो। तो शोकैड में यू कैन प्रोग्राम ऑल दिस एक्टिविटीज, ट्यून द थिंग विद द सॉन्ग। सपोज आपको एक सॉन्ग के थ्रू उसको पोर्ट्रे करना पड़ेगा। सपोज आपको कुछ विजुअल इफेक्ट, ऑडियो विजुअल इफेक्ट दिखाना पड़ेगा विद द ड्रोन। हाउ टू डू दैट? So there will be some song, there will be some LED lighting, all these things, how it will get impacted. So some choreographer will be there, just we see in the cinema. So those choreographers will be responsible to simulate those activity. So say suppose you have a song for 15 minutes. So in that 15-minute song, all the drones in 100 drones need to play with each other. They will be emitting the LED lights. They'll also be tuning with the song, and you will be seeing the portrait in the sky. एक इफेक्ट आएगा। तो वो सब चीज करने के लिए यू नीड टू हैव द डेडिकेटेड सिमुलेटिंग सॉफ्टवेयर। दोज आर नॉट द कन्वेंशनल सॉफ्टवेयर यूज इन मेकाट्रॉनिक्स, दैट इज डिफरेंट। एनसीस, डैनफोस, एचएफएसएस, सिमुलिंक, these आर ऑल द मेकाट्रॉनिक्स रिलेटेड सॉफ्टवेयर। उसके साथ ये सॉफ्टवेयर का लेना देना नहीं है। बट शोकैट जो सॉफ्टवेयर मैं बोल रहा हूँ, दैट इज ऑल्सो अ पेड सॉफ्टवेयर, मानी उसको खरीदना पड़ता है।
अच्छा, okay. Then what will be the cost means for the annual subscription? Uh, approximately.
एनसीस with all the packages, it will be near about once a year.
Okay. Okay.
And Simulink, you can take around 25 lakhs. Danfoss का जो सॉफ्टवेयर है, it will be near about 50 lakhs.
Okay.
ANSYS is very very costly. माने I
Sir,
am talking about the mechatronic software including all the packages. All means everything. माने mechanical, electronics, thermal, everything.
So
sir, for
this
a drone startup, how much investment is needed, sir?
It depends on what type of drone you are trying to build up. If you are trying to build up some drone only for surveillance, then that investment is not that much. Around 15-20 lakhs, you can build up the protos. If you are trying to build up the drone for logistics sector, then it will be near about 1 CR plus initially. To build up the
and,
Sir,
drone, I am talking about building the drone, the proto drones.
and for
sir,
defense purpose.
Defense, it depends what type of architecture you want to deploy. Because in defense, the drone body is not that much fixed. You can have the mini size, you can have the mid size, you can have the large size, you can have the switch platform. So in switch platform, you need to design the fuselage like the aeroplane. Inside that fuselage, you will be embedding all the electronics part. So that will be heavier in size, that will be bigger. The endurance of those drones are much wider compared to that of the quadcopter or the micro category drones. So sometimes the requirement for the defense, say suppose you are building the drone for defense, which will be used in the warfare. Like I think you have read in LinkedIn that two engineers from BITS Pilani, Hyderabad, they
Yeah,
have
yeah,
built
they
up two
got the
drones.
contract. Yeah,
Uh, so those drones will be flying at a speed of 300 kilometer per hour. So those drones will be costly. They
The
have built up on an
kamikaze
amateur
drones, right?
basis, kamikaze drone. So those will be costly because they will be used in the warfare. So they need to connect the payload as the missiles or different kind of bombs. So that bombs or the missile need to have the very secure RF communication with the ground control station. Otherwise, they will hit the wrong target.
yeah, correct, absolutely, correct. Thank you,
sir,
thank you.
sir, can you develop a module for the business side of the drones also, sir? Can you,
See, I can develop, but in this way, I cannot work on the drone. Drone for forming a drone, it need a bigger team. It is not the work of a single person because lot many things are involved inside a drone. It involves the power electronics team, it involves a mechanical team, it involves an electronics team, it involves an IT team who will develop the UI. It needs an experienced RF team. I basically work in the RF side. It needs an
sir,
embedded team.
how about the government scheme which help in the start for the startups, sir? Can you explain about those things also, sir?
Government actually, lot many, actually it is not a central government based scheme. If you talk about the different state governments, like for Maharashtra or Telangana or West Bengal or other state, so under the small investment scheme, na, so they are funding something. Suppose you come up to the government with some proposal that, okay, I have this kind of proposal for developing this drone, and the application area will be like this. Say, I'm giving an example. It's a very good example and a good question also. So just 10 minutes. I will not take much time. I need to go to the topic also. This is only for your knowledge. Suppose the police sector, what happens now? uh, you know that when a meeting happens or when a political convoy goes on, so so many people, so many police need to be deployed to a particular location to see that whether the mobs are not dispersed, there is no kind of violence in the in the path and all these activities, right? So all these kind of things can be monitored by drone. What they will do, they will just hover the drone through the drone pilot on the areas where these mobs are going on or the political meetings and all these things are going on, and through artificial intelligence they can give the certain kind of alerts which the police will demand, and they will send to the remote station. So there will be some control station in the police headquarters. Automatically they will get the data from there, and if they see any kind of discrepancy, then they will go there and they will arrest the people or they will do some kind of activity. So if anyone have any idea that, okay, I have this scheme, I have this technology with me, and I can develop it for your police department. So if you give me some funding, then I can develop it for you and I can sell it to you. So I know 2 3 companies in India. I am working with some of them as well. So they are developing this kind of drones, and police department is taking that. So initially they are taking that for the pilot run. Say 2 3 drones they are taking. They are seeing the operation for around 6 months. After that, they will give the bulk order. Now, if I talk about the Maharashtra police, so Maharashtra police, you imagine in the Maharashtra state how many police stations are there? What are the places where lot many violences can happen? See, if I talk about Mumbai, if I talk about Nagpur, if I talk about Pune, so how many police stations can be there? So they can do the traffic control management, they can do the mob management, they can do the political meeting management. All these things you can do. And nowadays you can employ lot many good cameras with artificial intelligence integrated to it. You can give the data feed on a real time basis. So police department are accepting that. You know, in this Shravan month, so there is a pilgrim that is called Pandarpur. There is a place called Pandarpur. I don't know whether you know or not. So
Yes,
Pandarpur,
sir.
lot many people used to go. So that entire mob, what to say, surveillance is being done by drone. Police was not there. This year it started. The in the police station they positioned some camps, and in that camps they got the real time feed. It can happen now that with the pilgrims, medical assistance is required. They will see that any kind of violence is there or not. All these things are being captured now by drone.
Sir,
Lot
how
many
about
use
for
cases are
the
coming.
agricultural drones, sir?
In agricultural drone, you can what to say? You can throw the pesticide from the top. You can sprinkle water. You can check the quality of the crop. Lot many application cases are there, boss. If I tell you, that will take around 2 3 hours separate class. I can tell you lot many application for agriculture, for mining area, for police department, for defense sector. Lot many use cases are, though based on this, the drone is a booming technology now. Why? Because the application cases are becoming much wider. Where manually these things are being done, those will being done by the machine. You see that a big acre of land, 2 3 acres of land, and you need to plow the crop. You need to feed some pesticide, some water, some kind of minerals into it. I'm giving an example. Manually, you need to do these things over days. Now all these activities will be done by the drone. How? They can do fit with the robotics arm also. Drone can come fitted with the robotic arm. In the payload, you will be having the robotic arm. The robotic arm will do the work of the people. They will say, suppose now is the seeding time for the rice. Now what people do? They will say, suppose you are the owner of 2 acre of land. You will hire some people to plow the rice seed and all these things in the field. That can be done by the robotic arm. Drone will do the mapping initially. He will know the area of where the rice seed need to be implanted. Then in the payload they will connect the robotic arm, and the robotic arm will take the seed in its pocket, and slowly he will do the seeding or placing of the plant or the seed. Then you can sprinkle the water, you can sprinkle the pesticide, whatever you need. In agriculture, in pisciculture also, lot many ponds are there where fisheries is a major activity of earning. So in fisheries, what happens now? You need to measure the salinity or the particular quality of the water. What is the pH level of the water? What is the nitrogen content? What is the carbon content? What is the oxygen content for the better growth of the fish? So those all activity can be monitored by drone. Drone can sprinkle some kind of materials or minerals inside the water for the growth of the fish, because for the variety of the fish is different in different areas.
So the naval drones are different in the technology from the UAVs.
Which one?
Naval drones.
No. Drone is drone only. So technology wise, look and feel wise, that can be different. You can have a quadcopter, you can have a hexacopter, you can have a switch, you can have a logistics drone. Your endurance, your technology, that can be different, but the fundamental principle of the drone is same. On
Thank
what
you, sir.
basis commercial drone or naval drone is fabricated, on the same fundamental basis, your defense drone or the other high-speed drones are also fabricated.
Thank you, sir. Thank you.
Sir, I got one question
Yeah, please.
related to defense and maybe certain specialized government branches. When they go for a drone, is there any restriction on type of hardware? Like when I say type of hardware, specifically about open source hardware, they do allow those
Definitely.
open source
Definitely.
hardware?
No. Absolutely
Okay,
no.
okay.
Now in Indian defense, there is a strict restriction. Don't disclose it to others, that
Uh-huh.
you cannot use Chinese part.
Okay,
First of all,
okay.
the program is totally make in India. Okay.
Mm-hmm.
So
Mm-hmm.
the component, the electronic component, the mechatronics component, the assembled part, whatever you will be using inside the drone, that
Mm-hmm.
you can buy either from India or from US or from UK, but not a single part from China, including the battery.
So do we have competent companies which has got
Yes,
such
yes, 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 yes,
autopilot? Okay,
yes, 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 yes. I am using some autopilot in my organization that is coming from US. Some are coming
okay.
from UK.
Mm-hmm.
So you will be finding some commercial drone companies who are using the Chinese part, but they cannot sell those drone to defense. Defense will
Got
not
it.
accept any Chinese part. You need to
Okay.
disclose all your confidential things na, to defense for selling. They will ask you for the complete bill of material. So suppose you are forging, you are
Mm-hmm.
using the Chinese part, but you are mentioning the part you have brought from US. If they
Mm-hmm.
open the drone and inspect it, na, and if they
Mm-hmm.
find that you're using Chinese part there, they will ban your company.
Got it. Yeah.
And
Thank you.
what is the most Indian autopilot vendors or who develops in India for
Autopilot.
drones? Uh,
For drone, autopilots are being developed by majorly 4 or 5 good companies are there.
mm-hmm.
One you can have from L&T, one you can have from Adani, one you can have from one company in Bangalore, one company is there in Mumbai.
Why
See,
this L&T and Adani people will develop for smaller applications? They don't give us, right? They need a huge order like that, right?
definitely. Why they will give you one to quantity?
One to quantity.
And autopilot is basically comprising. See, yesterday I have discussed about the different features inside autopilot. Suppose you are building the autopilot PCB board, you need to have the communication module as the main fundamental block that you can buy from any company. Suppose you are not restricted to Chinese vendor, then you can buy the communication wireless LAN module from the Chinese vendor or from some vendor or supplier from US or UK, and the other parts you can buy from other company, and you can develop your own PCB board. See, there are two aspects in the autopilot. One is the hardware part, one is the firmware part. So you can, if you design your own circuit, your own PCB board, you are left with the programming. So if you get the programming part done by your team or by yourself, then your autopilot is done. You don't need to rely on L&T or Adani or any other company. You can build your own autopilot. Autopilot building is not that much rocket science that no one can do. The main challenge comes with the firmware. So that anyway companies develop. See, lot many reference code, lot many drivers that will be given by the distributor or supplier itself. Suppose you are using some modules from Texas Instrument. So if you go to Texas Instrument website, automatically you will get the device driver, automatically you will get the reference code. Texas Instrument have a very good field application team. They will guide you with the how to do your develop your firmware code. They will check your garbage data. They will check your schematics. You will get all this help.
Okay.
So what else application can be there in the defense sector of the drone?
In the defense sector, you can use the drone for surveillance. You can use the drone for mapping. You can use the drone for any kind of intrusion detection. Suppose in the borderline, some kind of intrusion or trespassing is happening in the no man's land or in the very much restricted areas. So those kind of activity you can govern by the drone, where people cannot move. Say you are moving in the Nathula Pass, where the temperature is minus 40 or minus more than minus 50. So the military personnel also get sometimes difficulty to breathe. So there you can use the drone automatically for surveillance. And those are very long endurance drone. And those drones, suppose you fly for 6 hours. So 24 hours, you need to fly 4 drones. So after 6 hours, it will be replaced by another drone. After 6 hours, again replaced by another drone, like that. You can do any kind of mapping. The defense tell you that, okay, in this desert area, I need to do a kind of mapping, a geographical mapping. That can be done by the drone. Lot many applications are there. So based on that, your payload, your algorithm, that will change. The hardware will remain the same for the overall drone, but the payload requirement will change.
Okay, okay.
Okay, can I proceed then? Any further question on
Yeah,
RF
yeah,
or? Okay,
yeah. We can proceed.
okay, thank you. Okay, so now we'll discuss about the modulation schemes and protocols. Frequency shift keying modulation represents one of the simplest and most robust modulation scheme for drone communication. Digital data modulates the carrier frequency by shifting between discrete frequency values, providing excellent noise immunity and simple demodulation circuits. FSK is commonly used for low data rate telemetry and control applications. Space spectrum techniques, like I told you just now, frequency hopping space spectrum and direct sequence space spectrum provide enhanced interference immunity and security for drone communication. FHSS rapidly switches between multiple frequency channels according to a pseudo-random sequence. So there are pseudo-random sequence generator which will do this kind of channel sequencing. While DSSS, direct sequence space spectrum, spreads the signal across a wide bandwidth using spreading codes. Spread spectrum techniques offer significant advantages, including improved signal to noise ratio, reduced susceptibility to narrowband interference, and enhanced security through signal hiding. These benefits make spread spectrum particularly valuable for military and security application. As I told you that basically we need to play with the frequency. We don't have anything else. So we have two things in our hand. One is frequency, the other is phase. Now frequency is very easy to handle. Phase is not that much easy. So whether we go for the 2.4 gigahertz frequency band or 5.8 gigahertz frequency band, what kind of bandwidth sharing we need to do? We need to do that by using different modulation schemes with frequency. So the two most enhanced or renowned frequency modulation schemes that is being used, that is the frequency hopping space spectrum and other is the direct sequence space spectrum. So what are the merits or the demerits of FHSS and DSSS that is being described in these two paragraphs? So that I think you can go through. It is not that much difficult. So in FHSS, it rapidly switches between the multiple frequency channels according to a pseudo-random sequence. While in DSSS, it spreads the signal across a wide bandwidth using the spreading codes. Now, spread spectrum techniques offer significant advantages, including improved signal to noise ratio, reduced susceptibility to narrowband interference, and enhanced security through signal hiding. These benefits make spread spectrum particularly valuable for military and security application. So in defense sector, obviously you can understand which kind of modulation it is being used. Orthogonal frequency division multiplexing modulation enables high-speed data transmission by dividing the available bandwidth into multiple orthogonal subcarriers. This technique provides excellent spectral efficiency and robustness against multipath interference, making it ideal for high bandwidth application such as video streaming and sensor data transmission. Modern drone communication systems increasingly adopt orthogonal frequency division multiplexing based protocols, including Wi-Fi 802.11 AC/AX. This is the IEEE frequency, IEEE standard. So IEEE Wi-Fi frequency standard is 802.11 AC/AX, and LTE technologies, long-term equivalent technologies, to achieve multi-megabit data rates essential for real-time video and sensor data streaming. So, orthogonal frequency division multiplexing modulation enables high-speed data transmission by dividing the available bandwidth into multiple orthogonal subcarriers. You know the carrier. So, the available bandwidth is divided into multiple orthogonal subcarriers by the orthogonal frequency division multiplexing scheme. This technique provides excellent spectral efficiency and robustness against multipath interference, because if we use the 2.4 gigahertz frequency band, we use some channel bandwidth. So there also, due to the adjacent cellular tower or other nearest ISM band frequencies, so lot of interference will come into picture. So in order to nullify the effect of this interference, if we use this OFDM modulation technique, then it will have an excellent spectral efficiency and robustness to mitigate this multipath interference, and making it ideal for high bandwidth application such as video streaming and sensor data transmission. Modern drone communication system increasingly adopt these OFDM based protocols, including the Wi-Fi 802.11 AC/AX. So there are lot many standards like 802.11 AC, BG, AX. So here they have mentioned AC/AX and LTE technologies to achieve multi-megabit data rates essential for real-time video and sensor data streaming. So whatever data rate or data streaming rate is applicable for 802.11 AC standard, that will not be the same for 802.11 BG or AX standards. That will be different. So if you see any kind of data sheet for this, any kind of Wi-Fi module, here there the IEEE standard for this Wi-Fi communication will be much wider. And if you go through the data rate or the bit streaming capability for this Wi-Fi module, that will also be different for all these standards. So for AC, what bit streaming or data rate capability it can withstand, that will not be the same for AX. Okay. Now we'll discuss about the control link systems.
I have a question.
Any question here?
Yeah, I have a question. Means
Yeah.
can we say that OFDM is better than sequence spread spectrum?
Yeah, we can say.
Or,
We can say.
yeah,
We can say.
thank you. Thank you.
Okay. Any other question? Okay, let's start with the control link systems. Manual control interfaces. Proportional control systems. Traditional radio control systems utilize proportional control channels that transmit analog stick positions and switch states to the drone's flight control system. These systems typically employ pulse position modulation (PPM) or pulse code modulation (PCM) to encode control command into radio frequency signals. Now, what is meant by this paragraph? Traditional radio control systems utilize proportional control channels that transmit analog stick positions and switch states to the drone's flight control system. Now, whenever this control interface will come into picture to link to the control systems, this will typically employ certain modulation scheme. So one is called the pulse position modulation scheme and the other is called the pulse code modulation scheme. So for control link systems, for the control interfaces, we can either go with the pulse position modulation scheme or the pulse code modulation scheme. These are basically the digital modulation scheme to encode control command into radio frequency signals. So by this modulation scheme, either PPM or PCM, which are inherently the digital communication modulation scheme, this will encode what? The control command into radio frequency signal. Modern proportional control systems support 8 to 16 channels, enabling control of flight surfaces, camera gimbals, payload systems, and auxiliary function. The control resolution typically ranges from 10 to 12 bits, providing smooth and precise control authority across the full range of aircraft capabilities. Digital control protocols, advanced control systems utilize digital protocol such as SBus, DSM, CRSF, and that provide enhanced reliability, lower latency, and expanded functionality compared to traditional analog systems. These protocols incorporate error detection and correction mechanisms while supporting higher channel count and faster update rate. Digital control protocols enable bidirectional communication, allowing the receiver to transmit telemetry data back to the transmitter, including battery voltage, signal strength, and system status information. This capability enhances situational awareness and enables proactive maintenance. This is very, very important. I told what? That whenever a drone is flying in the air and it is continuously transmitting the telemetry data and surveillance, say suppose we are using a camera, so the video data is streaming, the real-time data is being sent to the ground control station or the communication box. Now suppose you are getting the data from the battery management system as well. Suppose this is the state of the health or the state of the voltage or current or temperature for a particular battery system used in the drone. Now if the battery voltage is below a critical value, the drone is blind, it is going on flying. The communication box need to trigger an alert message or alert data back to the drone and to say your battery voltage is low. You cannot carry on the flight to the fullest extent. So you abort the mission and come back to the home location. So these digital control protocols will enable the bidirectional communication. Why bidirectional? Because on one side, you are sending the data from the drone to the communication box, and at the other side, the communication box is sending some alert data back to the drone and saying that this is bad or this is good. Now you want to abort the mission or you can come back to the home location or the base location. That's why it is a bidirectional data flow, allowing the receiver to transmit telemetry data back to the transmitter, including the battery voltage. Transmitter means the drone side, including the battery voltage, signal strength, and system status information. Any question here? Okay.
Quite good.
Autonomous, yeah. Anyone?
No, we can proceed further.
Okay. Autonomous control integration. Mission planning interfaces. Autonomous drone operations require sophisticated mission planning and monitoring capabilities that extend beyond basic manual control. Ground control stations provide graphical interfaces for waypoint definition, flight plan creation, and real-time mission monitoring. I told you earlier that you need to have a GUI. So that GUI need to be connected with the COM box. So whenever you are receiving the data from the drone to the COM box, that COM box will route the data further to the UI for further processing, because whatever data will be received from the drone, that will basically be the raw data. That will not be the processed data. And the user that will not understand the raw data. So they will be understanding the processed data. So in order to understand the processed data, so there are certain interfaces that are built up in the back end. And whenever in the real time, they will get that feed from the raw data, they will automatically process that raw data and they will be showcasing that in the screen. So there are a lot many control or the portal parameters that is being there along with the communication box. Like I have used something from GetAC or something kind of tablet from Panasonic. So there, those console will be basically meant to visualize those kind of data, the process data. So whatever raw data we are getting from the drone and is being received at the communication box, so that will be processed further by this tablet or this kind of single uh, SBC, the single board computer, and they will be processing the data further to showcase on to forward further data analytics. Okay. So mission planning systems incorporate terrain databases, no-fly zone information, and weather data to optimize flight path and ensure safe operation. Advanced systems support complex mission profiles, including survey patterns, search operation, and coordinated multi-vehicle missions. Command and control, control protocol, standardized command and control protocol such as MAVLink, Micro Air Vehicle Link, enable interoperability between different drone platform and ground control stations. So these are the secure communication protocol I talked earlier. So MAVLink is one of them. So Micro Air Vehicle Link that is being used as a standardized command and the control protocol to enable the interoperability between the different drone platforms and the ground control system. These protocols define message formats for mission command, status update, and parameter configuration. Mavlink supports both mission-oriented command, waypoint, takeoff, landing, and direct control command like altitude, velocity, position set points. The protocol includes acknowledgement mechanisms and error handling to ensure reliable command execution in challenging communication environments. So Mavlink is that kind of protocol which are basically oriented both for the mission oriented commands like you can get the waypoint data, takeoff data, landing data, and direct control command. Direct control command will include the altitude data, velocity data, the position set points, including the lat long and all these stuffs. The protocol includes acknowledgement mechanisms and error handling to ensure reliable command execution in challenging communication environments. Okay, any question here for the autonomous control integration?
Yeah, means wavelength and the radio frequency both are different, and the uses
Different,
also.
different, 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 different. Radio frequency is basically the frequency communication channel based on which you are communicating the data. And Mavlink is a secured protocol system. This protocol system provides the interoperability between the different drone platform because whenever the drone is flying, the drone and the GCS, they also need to sync in tandem, right? So for that, you need to have some secured access path. That secured access path is being provided by Mavlink. Here, this micro air vehicle link is given as a Mavlink protocol. Other protocol can also be employed. You can use some secured field bus protocol like Modbus or TCP/IP. That also you can use.
Understood. Yeah. Thank you.
So this over this Mavlink, can we once the drone is back, suppose the drone has done the surveillance and it has recorded some videos and all. So once the drone is back, can we get this data to our GCS through Mavlink?
Huh? Definitely you can get. This Mavlink
Okay,
protocol is being used to do that kind of activity only. It will be
okay,
enabling a secured communication path between your UAV and the GCS. And the portal or the UI that will be connected to the GCS only. So through the GCS, through the Mavlink, you will get two kind of command, like one for the waypoint takeoff landing and the other for the direct control command. So that you can set unless and
means
until you can.
gigabytes of data transaction can happen through this.
No, this is the common interface.
Come,
Mavlink is basically the common interface. So there you are
hmm,
setting up the command for
commands.
waypoint, for
Okay.
takeoff, the landing, the digital direct control command that you are setting there. So that also needs some protocol to do execute, na? That is the Mavlink
Hmm.
protocol.
Okay, okay. Means data, suppose it has recorded some data, gigabytes of data, so that we can't take through the GCS once it lands nearby to
Through the
GCS.
Mavlink you cannot take.
Through the
You
Mavlink
can
we
take it
cannot
through
take
the
it.
you can take it through the LAN interface.
हाँ,
कॉम
LAN
कॉम
मतलब we
बॉक्स के
have
पास,
to connect.
हाँ,
Hmm.
आपके कॉम बॉक्स के पास डेटा आया, वो डेटा जो आया वो
Hmm.
रॉ डेटा आया. अभी रॉ डेटा
Hmm.
को प्रोसेस करके जो आपका आएगा वो कोई कंसोल पे आएगा. दैट कंसोल इज योर गेटैक टैबलेट और पैनासोनिक टैबलेट और सिंगल बोर्ड कंप्यूटर. अभी उसमें कैसे आएगा? यू नीड टू कनेक्ट समथिंग फ्रॉम द जीसीएस टू द एसबीसी, राइट? दैट इज द
Correct,
LAN
correct.
connectivity, the Ethernet interface.
Yes, yes. Okay, okay, understood. So Mavlink is only for commands, nothing else.
हाँ.
Yes, yes. Okay.
But
Thank you.
but can it be that wavelength, can it be intercepted by means NAV, um, like jabbing the frequency? So is it possible that wavelength also can be interfere?
How? Mavlink protocol is used to set up the common interfaces. Command control भी तो आपको देना पड़ेगा ना.
Mhm.
आपका जीसीएस के साथ यूएवी को तो कम्युनिकेट करना पड़ेगा. तो कम्युनिकेट कैसे करेगा? दे विल बी सेटिंग अप सम कमांड फॉर द बाई डायरेक्शनल डेटा फ्लो. अभी उसके लिए आपको कुछ प्रोटोकॉल पाथ चाहिए. दैट सिक्योर प्रोटोकॉल पाथ इज योर मैवलिंक कम्युनिकेशन प्रोटोकॉल.
this Marilyn, when we talk about the swarm drone, like
हाँ
master slave
हाँ
uh, interface,
हाँ
this same is applicable to swarm drone also.
हाँ, स्वॉर्म ऑल्सो मास्टर के साथ स्लेव का जो कम्युनिकेशन होगा उसमें आप यूज कर सकते हो। मास्टर को भी तो स्लेव के साथ कमांड कमांड कम्युनिकेशन तो करना पड़ेगा, वो कैसे करेगा? उसमें भी बैबलिंग आप यूज कर सकते हो। ओके।
Yeah, yeah, okay.
Now we will go with the telemetry and the data transmission. Now, real-time telemetry systems, flight parameters and status telemetry systems continuously transmit critical flight parameters, including position, altitude, airspeed, battery status, and system health information. This data enables ground operators to monitor aircraft performance, detect anomalies, and make informed decisions about mission continuation or modification. Modern telemetry systems transmit data at rates ranging from 1 to 50 Hz depending on parameter criticality and available bandwidth. GPS position updates typically occur at 5 to 10 Hz, while altitude information may be transmitted at 20 to 50 Hz for application requiring precise monitoring. This is only for your sake of knowledge. माने it is not absolutely true that 20 to 50 Hz में ही वो ट्रांसमिट होगा, नहीं तो नहीं होगा, वो उसमें प्लस माइनस भी हो सकता है। Sensor data streaming, advanced drone platforms incorporate multiple sensors, generating substantial data volumes that must be transmitted to ground systems for processing and analysis. Environmental sensors, cameras, and specialized payloads can generate megabytes of data per second, requiring high bandwidth communication links. Data compression techniques, including lossy and lossless algorithms, reduce transmission bandwidth requirement while maintaining data integrity. Adaptive compression systems adjust compression ratios based on available bandwidth and data criticality. So this is basically the different ways on how we can compress the data, we can maintain the integrity, what is the different frequency span for application which requires the precise monitoring, how the GPS position updates, that at what frequency interval it generally updates. The data rates can be ranging from what to what frequency band. So these are only for your information. Generally, in the processing of the UAV, this kind of information or specs are being followed. Okay, data logging and storage. Onboard data recording and comprehensive data logging systems record all flight parameters, sensor readings, and system events for post-flight analysis and regulatory compliance. Modern for defense, it is the DGCA compliance. Modern systems utilize high-capacity flash memory to store hours of detailed flight data, including high-resolution sensor measurements. In some of the modern drones, we are using the eMMC drives. So there, the flash memory chips are not used, or the SD cards are not used. We are using uh, the the PCB-based chips, which are basically the eMMC memory chips, which basically store or the data. So it can have the capacity till in GB. So in memory, which is in MB or say till restricted to 1 GB, for eMMC, we can use 32 GB or 64 GB of storage capacity, or 128 GB of storage capacity, depends. So data logging systems must balance storage capacity with data resolution and retention requirements. Critical parameters may be logged at full resolution, while less important data is sampled at reduced rates or compressed to conserve storage space. Ground-based data management, ground control stations provide data management capabilities, including real-time data visualization, historical data analysis, and automated reporting functions. These systems often integrate with cloud-based platforms for data storage, sharing, and collaborative analysis. Advanced data management systems incorporate artificial intelligence and machine learning algorithms to identify patterns, predict maintenance requirement, and optimize mission planning based on historical performance data. Okay, so far any question? So this is only for knowledge. There is nothing to have some deep diving in this topic, basically in this paragraph. If you have any
Sir,
question, you can. Yeah.
if we know about the IT as well as the electronics, can we get the
Uh-huh.
jobs, sir, in the drones of the companies?
Tell me once again.
If we concentrate on software and electronics, sections of the drones. Can we get the jobs in the companies, sir? Drone companies, sir?
Definitely you can get.
Okay, sir.
Definitely you
Thank
can
you, sir.
get. So there are two, three aspects. One is the conception about your mechanical fixing, mechanical part, and other is the conception about the total embedded part, including the RF. So embedded and RF include not only the hardware but the firmware as well. So if you have the knowledge about the embedded firmware, if you have the knowledge of the analog and the digital electronics, then definitely you can get the job in drone industry. Basically, it is all about electronics, right? Whether you are manufacturing a drone, whether you are manufacturing a car, there is nothing. So electronics is electronics only.
Okay, sir. Thank you, sir.
So any question on this data logging and storage?
Yeah, I have one question. Uh, Data logging,
Hmm.
because it records all flight parameters,
Correct,
sensor readings, and the
correct.
system events. So, is there any possibility that this data logging data which is logged can be intercepted by the enemy?
No. Once your data is logged in the device, in the hardcore device, that cannot be intercepted. So when you are streaming the data in the real time, that
Mm.
time the interception can happen. But once you are logging the data in the real time, say in the memory chip, that
Mm.
cannot be intercepted unless and until you destroy the drone.
Okay, got it. Thank you.
Like you had about the, or for flight, you had about the black box, right?
Correct.
For any kind of
Correct.
airplane, aeroplane, you have heard about the black box.
Mm.
So black box is basically the recording device on the any kind of accidental or any kind of incident that happened inside the flight. So that cannot be intercepted. So once the plane get destroyed or once the plane get returned back to the safely to the location, you can take out the black box and you can retrieve the data. Similarly for drone. Okay, any questions so far? I think today we'll
Yeah.
stop here. So we can have 10, 12 minutes for discussing the questions. Next class, we'll start with the video and the imaging systems. It will take lot many times. I cannot complete that in very quickly. Lot many things are there to tell. So better stop here. Next day, fresh, we'll start with the uh,
Sir,
video and the
um,
imaging system. Yeah, please tell.
not a technical question, but is
Yeah, yeah.
there any way to access recorded lectures on phone?
Which one?
Is there any way to access recorded lectures on phone?
Recorded lectures on phone. That I think you need to talk with the admin team. These sessions are anyway recorded. So how to get that recording in phone, that they can tell. I don't have the authority to share that. So you can connect with the EdYoda team, admin team. They can guide you on this. I think there is possibility. But how to get that, that I don't know. They can guide you on that.
And not even the video. We are not given the PDF file also for this. So
That you
where
can download, no? I think that you can download.
okay from our login account or
Yes.
okay, okay, thank you.
Technical, any question you have, please. We have 10, 12 minutes. You can ask any question.
Sir, I have a question. Do communication like with drone happen using satellites? Like, do communication happen with satellites?
Definitely, because in the drone, you are connecting the GPS receiver. So the GPS receiver will be communicating with the satellite only. So whether you are connecting with the GLONASS, with the IRNSS, or with the GPS, or with the NAVIC, so all these things need to be connected with the satellites only.
I mean, streaming and everything, like with GPS and other positioning system. I mean, it might not be like a two-way or a stream communication
No, no, no,
kind
no,
of
no.
thing.
From the satellites, you are getting only the lat. You can mute your off. From the satellite, you will get only the lat long parameter by the process of the triangulation. Suppose your constellation is supporting of 12 to 14 satellites, and your GPS receiver is able to latch with the 6 to 8 satellites. So based on the 6 to 8 satellites, based by the process of the triangulation, you are getting the lat long parameter. These lat long parameters, either with the DGPS or the GPS or the real-time kinematics, all these things are required. So those data need to be streamlined by the real-time data streaming to your ground control station. They have nothing to do with the satellite. With the satellite, you are getting only the lat long parameter, degree, hour, minute, second, interval, those kind of data parameter. And that need to be triggered in real time to your ground control station. That streaming you need to do. Otherwise, you will not get the telemetry data. Your telemetry data will record this information, position information, and the time information. So that position and the timestamp that you will get from the GPS receiver module through the satellites.
Okay, sir. Thanks.
Sir, can you explain how the jamming and anti-jamming of the drones work?
Well, that is a very complex modulation scheme. Jamming is basically to hamper the propagation of certain frequency band. In that way, you want to nullify the transmission of the data. And anti-jamming is the opposite of that.
Okay, so
Okay,
like,
so
do they
hmm,
jam like all the like they can't jam all frequencies, right? So
no, they cannot jam all the frequencies because they will not be knowing all the frequency band. If they know all the frequency band of your design, then the design will be forged, na? They can know for
right,
any kind of jamming device, they can know the basic center frequency. But as I told you earlier, they will not know the lower frequency band and the upper
right.
frequency band. They will not know the F1 and
The
the F2
bandwidths are
limits.
not known.
Uh,
So then, like, it still works, right? But how does it? If they don't know it, they still have jammers.
because because your basic intention when you are developing a drone is the normal flight. You need to execute the flight, you need to capture the data. And if the enemy they put some jammer in your device, you will not be able to continue with the flight or capture the data. So now you need to come with some mechanism in your drone system itself that it cannot be able to the enemy, you will not be able to jam the device. That is why you need to put some anti-jamming device in your drone. So if they put some jamming in the vicinity also, they will not be able to capture and nullify your data.
Okay, okay. So they try to jam the central frequency, and this is
They
uh,
will be trying to jam your central frequency, but they will be not be knowing your
okay,
bandwidth. Your bandwidth
okay,
span is
okay,
your
okay,
USP
okay.
that you are knowing as a designer.
Got it. Understood. Thanks.
So, sir, that F1 and F2 will always be harmonic of that center frequency or
No,
no?
no.
No, no.
F1 and
Hmm.
F2 are basically the plus minus component of your bandwidth. I told you, na, F1 is
Hmm.
equal to FC minus bandwidth by 2, and F2 is equal to FC plus bandwidth by 2. Harmonics are
Oh,
the multiples or the submultiples of the center frequency.
yes, yes. Okay, okay. Thank you. And so for defense, now for since you are working in defense, so defense definitely they will not be using this 5.8 and this 2.4 frequencies because this is
No, no, no. They are
no.
using. They are using the dual band.
Oh, they are using this frequencies only.
Huh? They are
Oh,
using
they
the
are
2.4, they are using the 5.8. Initially, when the drone was manufactured, they are using only 2.4. But in the new designs, they are incorporating, they are trying to incorporate, they are asking in the, they are giving in the specification that you need to use the dual band. You need to use both, you need to have the transceiver module both for 2.4 and 5.8.
సరే ఇందులో పెట్టే చాలు మంచం మీద ఉందని అక్కడ కూర్చుకుంటుందని భయపడుతున్నాను నా గురించి
but why मतलब why can't they use some secret frequency कि जिसका मतलब enemy can't know about that frequency even though even
आपको
secret frequency also.
आपको उस रेस्पेक्ट में मॉड्यूल भी मिलना चाहिए ना. मान लो आपने कोई फ्रीक्वेंसी सेट किया 7.4 गीगाहर्ट्ज एज्यूम, तो
हम्म
7.4 गीगाहर्ट्ज का आपको तो मॉड्यूल भी मिलना चाहिए. वो मॉड्यूल तो आपको मिलेगा नहीं. जो कॉन्वेंशनल मॉड्यूल, जो वायरलेस लैन मॉड्यूल मार्केट में बिकता है, दैट इज बेस्ड
हाँ
ऑन सर्टेन स्पेशलाइज्ड फ्रीक्वेंसीज. माने व्हाट टू से 2.4, 5.8, these are the readily available specialized frequency. कुछ कस्टमाइज फ्रीक्वेंसी के लिए नहीं मिलता है.
ओके 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 सो मतलब डिफेंस भी कोई कस्टमाइज देता नहीं लाइक सपोज दिस टाटास एंड एलएनडीज एंड सो दे कैन फ्लोट इंक्वायरी ना एंड दे
कैसे
कैन
देगा?
आस्क
हु विल
नहीं
प्रिपेयर द एसिक? वायरलेस लैन मॉड्यूल जो ऐसिक है वो बनाएगा कौन? डिफेंस तो वो बनाता नहीं है। डिफेंस कैन ओनली फ्लोट द स्पेक। वो स्पेक में भी अगर वो कस्टमाइज फ्रीक्वेंसी मांगेगा, which manufacturer will develop that?
Oh, okay. So that is the main restriction because of which वो 2.4 and 5.8 ही बोलते हैं,
हाँ,
not other than that.
नहीं कैसे होगा? मान लो यू
हम्म
आर यूजिंग सम कम्युनिकेशन मॉड्यूल फ्रॉम यू ब्लॉक्स, तो
हम्म
यू ब्लॉक्स से साइट में आपको जाके चूज करना पड़ेगा बेस्ड ऑन योर रिक्वायरमेंट। अभी उसमें आपको 2.4 और 5.8 ही मिलेगा। आपको अगर 7.4 में चाहिए तो आपको मिलेगा ही नहीं ना। आपको अगर मॉड्यूल ही नहीं मिलता है तो आप यूज करोगे कैसे?
Okay, okay, okay. मतलब from scratch we can't develop anything.
नो
मतलब we have
नो
to
नो
use
नो, ये
whatever.
तो एक ऐसिक है बॉस। ये तो आप
हम्म
डेवलप नहीं कर सकते। यू कैन डेवलप द प्रोग्राम, यू कैन
हम्म
डेवलप द हार्डवेयर इलेक्ट्रॉनिक्स, बट यू कैन नॉट
हम्म
डेवलप द चिप। चिप तो जैसा है
हम्म
वैसा ही है।
correct correct. Yes, ठीक है, thank you. Yeah.
ओके, एनी क्वेश्चन फ्रॉम एनीवन? देखो आज टाइम है इसलिए पूछ रहा हूँ, अदरवाइज ये वीडियो इमेजिंग सिस्टम्स में टाइम लगेगा। आई कैन नॉट जस्ट रीड द पैराग्राफ एंड लीव इट हियर। कुछ टेक्निकल क्वेश्चन है फ्रॉम द लास्ट सेशन आल्सो, इफ एनीथिंग इज देयर यू कैन आस्क।
Yeah, my question was about can you explain in summary control link system, that is the manual control system interface? Why that is good?
So basically, the control link system, it encompasses the different methodologies or the different ways by which we can put some kind of modulation in the pathway of how the drone will communicate with your ground control station. So basically, the scheme that is being used in the control interfaces of the control link system is the digital modulation scheme. Now in digital modulation scheme, we basically use the pulse position modulation or the pulse code modulation. So in pulse position modulation, we basically tune with the reference bandwidth. So what is the rise time and the fall time or the pause time or the all over delay in the subsequent pulse, that is being taken care in the pulse position modulation. And in the pulse, someone is talking, can you go on mute? Okay. And in the pulse code modulation, we basically tune with the overall span of the pulse. So there the rise time, the fall time, or the overall duty cycle of the entire pulse is being taken care. So either we can compress the pulse or we can expand the pulse. So in that way, in the pulse code modulation, we step forward with the scheme. So either we can use the scheme for pulse position or pulse code. Okay. So these are basically used to encode the control commands into the radio frequency signals. Now, in the proportional control systems, it can support 8 to 16 channels. It can enable control of flight surfaces, camera gimbals, the payload systems, or the auxiliary functions. Now, the control resolution for any kind of control link system that can typically range from what value to what value, from 10 bit to 12 bit usually, but it can extend to 16 bit also or 18 bits also. It depends on the requirement, providing smooth and precise control authority across the full range of the aircraft capabilities. Okay.
Okay, okay, got it. Thank you.
And the other point that need to be remembered, that these digital control protocols, it enable the bidirectional communication. Not, it is not a unidirectional flow or a simplex flow. It is a duplex flow, allowing the receiver to transmit telemetry data back to the transmitter, including battery voltage, signal strength, and the system status information. This capability enhances situational awareness and enables proactive maintenance. For the fail-safe mechanisms also, these digital control protocols are essential. Okay. And the
Yeah,
next is the autonomous flight control integration. This autonomous control integration is basically the mission planning interfaces, that how you are doing the sophisticated mission planning, how you are monitoring the capabilities that extend the beyond the basic manual control, what the ground control station provides for the waypoint definition, flight plan creation, real-time mission monitoring. So all these things comes under the autonomous control integration. You need to have a dedicated UI to a single board computer, and that need to be connected to your GCS to certain communication channel. In our case, in many of the cases, use the Ethernet connectivity. So the LAN connectivity, you are getting the data, the raw data into a processed format, and then you are displaying that in the single board computer console. Okay. And the command interface between the com box and the communication module, that basically happens through the Mavlink protocol. This is all about these control link systems. Okay, I think it is clear, or any question further?
No, no question. Only thing, when we talk about this network technology, uh, yeah, in this drone engineering, that WAN,
Can you speak a bit louder? I cannot hear you properly.
yeah, can we use the WAN topology, area network?
We can
Hello.
use. We can use.
How we can use that, using what means radio frequency band, or hello.
See, this wide area network or the wireless LAN network or the Wi-Fi or the WiMAX, these are the different variants under the radio frequency communication. So these are specifically restricted to different frequency, different modules. So if you are using the wireless LAN module, the module will be different. If you are using the wide area network module, the module will be different. But all this communication will happen through the RF link only. You cannot avoid the RF link and establish communication path. So these are the essential path of the microwave communication. The RF and the microwave propagation encompasses all these things. You can encompass Zigbee, Bluetooth, Wi-Fi, WiMAX, wide area network, shorter range network, short range communication, long range communication. All these things are the part of the RF and the microwave propagation. So obviously RF will come into picture.
Yeah, thank you very much.
Okay, just one more question. The antennas which we are using, matlab, like amplifiers, which we are using on the ground station and on the UA, this drones, are the same. Like suppose 30 dB we are using on the ground station, so 30 dB we will be using on drones.
No, 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 no,
No.
no. First
Hmm.
of all, amplifier and antenna are two separate entities. If we are
Yes.
using the power amplifier module in the UAV side for
Hmm.
getting certain range, that is not the same amplifier need not be used in the ground control station. In the ground control station, you can use some higher power or low power, but that higher power or low power will not detect your range for the UAV.
Correct.
तो उसके
So
लिए
on.
हाँ बोलो टेल
So UAV के लिए maximum मतलब what we use basically maximum power output for the
मैक्सिमम पावर
RF.
आउटपुट डिपेंड्स ऑन द एप्लीकेशन. आपका
Hmm.
अगर रेंज एक्सटेंड करना है टू 100 किलोमीटर 200 किलोमीटर, उसके लिए जो आरएफ पावर कैपेबिलिटी लगेगा, आपको अगर चाहिए 5 किलोमीटर, उसके लिए वो नहीं लगेगा. बिकॉज यू रिमेंबर वन थिंग, इट इज नॉट अबाउट द आरएफ पावर, इट इज अबाउट द डीसी पावर ऑल्सो. द एंटायर
Hmm.
ऑपरेशन ऑफ दिस ड्रोन हैपेंस टू द बैटरी.
Hmm.
आपको अगर ज्यादा आरएफ पावर ट्रांसमिट करना है, उसके लिए जो बायसिंग मैकेनिज्म लगेगा, वो भी आपको सोचना पड़ेगा.
Right.
क्योंकि जो आरएफ पावर एम्पलीफायर हाई पावर आउटपुट के लिए होता है, जनरली द बायसिंग विल बी 58 वोल्ट, 60 वोल्ट, 48 वोल्ट. वो कैसे आपको मिलेगा वो डीसी? आपको बैटरी से ही फेच करना पड़ेगा ना. जितना ज्यादा वोल्टेज
Hmm.
वो बैटरी फेच करेगा, और जितना करंट, क्योंकि हाई पावर ट्रांसमिशन आरएफ पावर ट्रांसमिशन के लिए करंट भी ज्यादा चाहिए, तो आपका बैटरी भी ज्यादा जल्दी जल्दी ड्रेनेज होगा. और नहीं तो आपको ज्यादा एम्पियर आवर का बैटरी लगाना पड़ेगा. ज्यादा एम्पियर आवर का बैटरी लगाया तो योर वेटेज ऑफ द बैटरी
Wait.
विल इंक्रीज.
Right. Right. Yes.
So there is always a compromise. So you cannot just use the RF power as per your wish. जैसे
Hmm.
I have used in some of the application a 10 watt power amplifier. So initially the power amplifier that was given with the wireless LAN module, that have the capability to transmit till 30 dBm, mane 1 watt.
Hmm.
I need to increase it to 10 times. So I have designed an RF power amplifier. So that RF power amplifier will have a gain of around 40 dBm. Sorry, 40 dBm.
40 dB. Hmm.
हाँ, तो 40 dBm आउटपुट मुझे मिला
Hmm. For UAV.
फॉर यूएवी.
Yes. Yes.
So same power amplifier I have not used in the ground control station. क्योंकि ग्राउंड कंट्रोल स्टेशन में मुझे उतना पावर RF पावर का रिक्वायरमेंट है नहीं। क्यों नहीं है? क्योंकि मुझे ग्राउंड कंट्रोल स्टेशन के साथ तो कम्युनिकेट करना है मेरा ड्रोन के साथ।
correct.
अगर मेरा ड्रोन फुल रेंज में चला जाए, 100 किलोमीटर 200 किलोमीटर में चला जाए, तब मुझे वो हाई पावर रिक्वायरमेंट चाहिए इन द कम्युनिकेशन बॉक्स। और कम्युनिकेशन बॉक्स का और एक भी सुविधा है कि कम्युनिकेशन बॉक्स में यू नॉट यूजिंग द डायरेक्शनल ऑन द ओमनिडायरेक्शनल एंटेना, द डाइपोल एंटेना, यू आर यूजिंग अ पैच एंटेना, लार्जर ग्रिड एरे एंटेना। तो उसका अपर्चर एरिया बहुत ज्यादा है। तो जो एंटेना का अपर्चर एरिया ज्यादा है, तो उसका रेडिएटिंग पावर भी ज्यादा होगा। तो आपको ज्यादा एम्पलीफिकेशन का जरूरत नहीं होगा उसमें।
Okay.
कॉम बॉक्स का साइज बहुत बिगर होता है। इट इज नॉट लाइक द यूएवी साइज। कोई कोई कॉम बॉक्स में कोई कोई कॉम बॉक्स तो माउंट करना पड़ता है ऑन अ पोल। तो इट इज नॉट ऑन द ग्राउंड, इट इज ऑन समवॉट टॉप इन द टॉप। माने कोई बैम्बू का माने स्टील रॉड का या वुडन का पोल होता है, वो पोल के ऊपर वो कॉम बॉक्स माउंट होता है, उसके ऊपर वो ग्रिड
मास्ट के
एंटेना
ऊपर।
लगता है। हाँ, मास्ट के ऊपर।
Yes, yes. Okay, okay. ठीक है, थैंक यू। या
अच्छा, और कोई क्वेश्चन किसी का?
Sir, if possible, please show some photos of the drones and parts so that we can understand much better, sir.
That was already shown in the second class, I think. You have missed the second class?
Sir, I have missed that.
Okay. Uh, Actually, this picture is not there in
Correct.
the slide. So you can download the tutorials for the second class and all the classes. Definitely will get the picture there.
Okay, sir. Thank you, sir. Sorry for troubling.
No,
Good
no,
night,
it's
sir.
okay. So any further question from anyone?
We are quite okay.
Okay. So today I think we will stop here because the video imaging system that will take a longer time. So I don't want to go in a hurry with that topic. We will go slow with that topic because lot many questions will come there. So let us park it for the next class. So next Saturday we'll start with the video imaging system. Okay.
Okay, yeah.
Okay, sir. Thank you so much.
Thank you
Yeah,
everybody.
thanks, sir.
Have a
Thanks.
good day. Bye you all.
Bye.
Bye, sir.